Let's dive into the world of compute services in AWS. These includes Elastic Compute Cloud, EC2, the Elastic Container Service, ECS, the Elastic Container Registry, ECR, the Elastic Container Service for Kubernetes, EKS, AWS Elastic Beanstalk, AWS Lambda, AWS Batch, and Amazon Lightsail. So let's see what is compute. Compute resources are the brains and processing power required by applications and systems to carry out computational tasks via a series of instructions. These includes common server components like CPUs and RAM. In AWS, there are various services and features that offer compute power from hundreds of EC2 instances to serverless AWS Lambda functions. These resources can be consumed in different quantities and for different length of time, depending on your business requirements. Let's dive into the world of Amazon EC2. Amazon Elastic Compute Cloud or EC2 is a fundamental compute service within AWS, allowing you to deploy virtual servers within your environment. Today, we will explore the key components of the EC2 service. Amazon Machine Images. So we have Amazon Machine Images or AMIs. These are templates of pre-configured EC2 instances, enabling you to quickly launch new instances based on the defined configurations. With a wide range of AMIs available, including those from the AWS Marketplace and Community AMIs, you have plenty of options to choose from. So let's talk about instance types. These define the size of the instance based on parameters like CPU's memory and storage, from general purpose to storage optimized. This is a variety of instances families to cater to different performance needs. Moving up to the purchasing options, AWS offers on-demand instances, spot instances, reserved instances, and on-demand capacity reservations. Each option is designed to optimize cost and suit different deployment scenarios. Lastly, we will touch on EC2 tenancy. By default, instances run with shared tenancy, but dedicated tenancy options like dedicated instances and dedicated host are available for specific security and compliance needs. And that's a wrap up on our introduction to Amazon EC2. Stay tuned for more insights into the world of AWS. Let's see an overview of the Amazon EC2 container service, also known as Amazon ECS. Amazon ECS allows you to run Docker-enabled applications packaged as containers across a cluster of EC2 instances without the need to manage a complex cluster management system. The service abstracts the burden of managing your own cluster management system by passing that responsibility over to AWS, especially through the use of AWS Fargate. When launching your ECS cluster, you have the option of two different deployment models, a Fargate launch and an EC2 launch, each with its own set of benefits and use cases. So monitoring is taken care of through the use of AWS CloudWatch, which will monitor metrics against your containers and your cluster. The cluster is dynamically scalable, meaning you can start your cluster as a single small instance, but it can dynamically scale to thousands of larger instances. Amazon ECS provides a powerful and flexible solution for deploying and managing containerized applications, allowing you to focus on building great applications and deploying them across your scalable cluster. So introduction to AWS Elastic Container Registry or ECR. This service provides a secure location to store and manage your Docker images, allowing for easy distribution and deployment across your applications. The ECR consists of several key components, including the registry, authorization token, repository policy, and image. The registry is where you can host and store your Docker images, and it comes with the default URL with your AWS account. To access your registry, your Docker client needs to be authenticated as an AWS user using an authentication token. This token is obtained by running the get login command using the AWS CLI. Access to your registry and images can be controlled via IAM policies and repository policies, allowing for tougher security controls. You can assign permissions to each repository, controlling actions such as push and pull. So let's dive into the world of EKS, Elastic Container Service for Kubernetes. So Kubernetes is an open source container orchestration tool designed to automate, deploy, scale, and operate containerized applications. It's container runtick agnostic, meaning it can run Rocket and Docker containers. With EKS, AWS provides a managed service allowing you to run Kubernetes across your AWS infrastructure without having to take care of provisioning and running the Kubernetes management infrastructure in what's referred to as the control plane. The AWS account owner only need to provision and maintain the worker nodes. The control plane schedules containers onto nodes and tracks the state of all Kubernetes objects. In EKS, AWS is responsible for provisioning, scaling, and managing the control plane. Worker nodes are the responsibility of the customer and run as on-demand EC2 instances. To start using the EKS service, you will need to create an EKS service role, an EKS cluster VPC, install kubectl, and the AWS IAM authenticator. Create your EKS cluster, configure kubectl for EKS, provision and configure worker nodes, and configure the worker node to join the EKS. Your EKS cluster and worker nodes are now configured and ready for you to deploy your applications with Kubernetes. Now let's dive into overview of AWS Elastic Beanstalk. So Elastic Beanstalk is an AWS managed service that simplifies the process of deploying, provisioning, monitoring, and scaling a production environment to run web applications. It automatically handles the provisioning and deployment of necessary AWS resources, such as EC2 instances, auto-scaling groups, RDS database instances, and elastic load balancers. Once your application is up and running, you can continue to support and maintain the environment just as you would with a custom built environment outside of Elastic Beanstalk. It supports a variety of platforms and programming languages, including containerized applications using Docker, making it a flexible service for DevOps. Elastic Beanstalk provides a simple, effective, and quick solution for deploying web applications, making it an ideal service for developers and engineers. The service itself is free to use, but you will be charged for any resources that Elastic Beanstalk creates on your application's behalf, such as EC2 instances and applications load balancers. Elastic Beanstalk application consists of environments, versions, and environment configurations, each with specific roles and functionalities. When creating a new environment, you must specify an environment tier based on your web application functionality, choosing between a web server environment tier and a worker environment tier. The process for deploying and managing an application using Elastic Beanstalk involves configuring an environment, specifying the environment tier, providing application information, and configuring network and database settings. Let's dive into the world of AWS Lambda. To truly grasp serverless compute, we must first understood the traditional server setup. Imagine the freedom of focusing solely on your code and business logic without the burden of infrastructure maintenance and administration. AWS Lambda functions consist of three key parts: the input, the function itself, and the output. Your function represents your business logic and can be configured with important details like permissions and compute power. With AWS Lambda, you have the flexibility to choose from a variety of runtimes, including Java, Go, PowerShell, Node.js, C Sharp, Python, and Ruby. Custom runtime support is also available for languages not natively supported. Your Lambda function can be invoked through various methods, such as the console, SDK, HTTP endpoints, or triggers from other AWS services. Once triggered, your function can make calls to downstream resources like DynamoDB and SNS. When it comes to cost, you'll only pay for the resources you use based on the number of requests, duration of code execution, and the allocation compute power. AWS Lambda offers a seamless, cost effective solution for running your application code. Embrace the power of serverless compute with AWS Lambda. AWS Batch. AWS Batch is designed to handle batch computing workloads that require a large amount of compute power spread across a cluster of resources. It's ideal for tasks like training machine learning models and conducting large scale data analysis. With AWS Batch, you can seamlessly create a cluster of compute resources that's highly scalable and takes advantage of the elasticity of AWS. AWS handles all the provisioning, monitoring, maintenance, and management of your clusters, saving your time and resources. AWS Batch consists of jobs, job definition, job queues, and compute environments. These components work together to define, schedule, and execute batch computing workloads efficiently. That's a quick overview of AWS Batch. Thank you for joining us and best of luck with your continued learning. Amazon Light Sail. Amazon Light Sail is a virtual private server or VPS backed by AWS infrastructure designed to be simple, quick, and very easy to use at a low price point for small scale use cases. You can run multiple Light Sail instances together, connect it to other AWS resources, and access it either via the AWS console or directly to the Lightsail homepage. To create a new instance, simply select your region, platform, blueprint, launch script, key pair, and instant plan. It's that simple. Once your instance is up and running, you have a number of management and monitoring options, including connect, metrics, snapshots, storage, networking, domains, tags, history, and delete. Amazon Lightsail provides lightweight, cost-effective solution for small projects and use cases. So thanks for joining us for this quick introduction to Amazon Lightsail. So let's carry on.